I can start my class, and the other students can, I think, join during this class. Okay, so already how many 27 students joined. Uh, okay, okay. I share my laptop screen. So I hope all of you seen PowerPoint presentation. Is it? No? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So the little a small portion of air diagram is left. So I can complete that first. And I hope all of you enrolled in module in the database management system course. Is it? And also there I
Yes,
uploaded
sir.
the annotated PPT, so you can download from there. And though most of the students have entered their roll number in module, so very few students there is a roll number is missing. So please, all of you uh, include your roll number in the module profile. Okay. Now, how we can represent the generalization or specialization as a table form? So there are two ways there. The first way, we form a table for the higher level entity set. Okay, for the higher level entity set, and for each of the lower level entity sets, the table consists the what are the column in the table which correspond to the each of the lower level entity set, which include the primary key of the higher level entity set and the descriptive attribute, that is the local attribute. For example, for example, uh, the person is here a higher level entity set, and lower level entity sets are employee and customer. Okay, and this one, this generalization and as well as the specialization I have already discussed in our previous classes. Now question is actually what are the table, if we convert this one in a table for the relational database, what are the possible tables? So one table for one table for person. Okay, higher level entity sets. And what are the attributes? All the descriptive attributes, that is the name is the one of the column of the person, street is the another column or field of the table person, and city is the another field. Now in case of lower level entity set, employee and as well as the customer, what are the attribute or what are the field or what are the column in a table, corresponding table? Of course, two lower level entity sets are there. That means two table is required for the employee, one table for employee and another table for customer. So employee table consists column, which one is the primary key of the higher level entity set, which one is the higher level entity set, person is the higher level entity set, and here primary key, we assume the name is the primary key. So employee consists the name and as well as the local or descriptive attribute salary. So employee table, when we convert this one as a table, employee table, the name of the table is the employee table. What are the column? One column for name, that is the primary key of the higher level entity set, and another column salary, which is one of the local attribute or descriptive attribute. So similarly in case of customer. So for this generalization and specialization, uh, it can be converted into three table. One is the person higher level entity set, customer lower level entity set correspond to the table is the same name, and employee table. And these are the attribute. The person table consists of what are the field or attribute or I mean column. in that person table each of the attribute. You can see here name, street, and city. Okay, but up to that, any question? But in this method, drawback is if we want to get information, to getting the information need to consult sometimes more than one table. Okay, for example, uh, if we want to gather, or if we want to collect the information about all the employees, then need to access the two tables. What are the tables? Which table need to be accessed? Not only the employee table is sufficient, not only this employee table is sufficient, need to be consult also the person table, because the person table consists the where address of the employee, that is the street, city, and so on. For simplicity purpose, we can consider the three attribute or three column value for the person, person table. Is it clear? So for example, suppose another example, so this is the another generalization or specialization. The account is the higher level entity set. Is it? The account is the higher level entity set, and what are the lower level entity set? What are the lower level entity set? Lower level entity sets are saving accounts and checking accounts. These are the lower level entity set, and they are descriptive or local attributes. For the saving accounts is the interest rate, and checking accounts is the overdraft amount. Am I audible, please? Am I
Yes, sir.
audible?
Yes, sir. Yes, sir.
Yes,
You're
sir,
audible.
audible.
Okay. Okay. So, so for that actually, if we convert this one in a table for the relational database system, so what are the table? By this method, one table for account. This is the account is the one of the table. In this table, what are the column? Account, number, and another is the balance.
Balance.
Is it? Balance. So there is another table. What are the table name? Table name is the say saving account. Okay. In saving accounts, what are the columns? One column is the primary key of the higher level entity set. Which one is the primary key of the higher level entity set? Account number. Okay. And another column is the local attribute, that is the interest rate. Interest rate. Okay. So this is the table for saving accounts. Okay. Similarly, for the checking accounts, there is another table which consists of primary key, account number, and as well as the overdraft amount. So for this, actually three tables. One is the account table, saving accounts table, and another one is the checking accounts table. Okay, this is the method one. So in this method, what is the drawback? Actually, I told you the need to be sometimes need to be consult more than one uh, table to get the information. Another method, form a table for each entity set with local attribute and inherited attribute. So in case of previous figure, here person, employee, and customer, three table is required. In that case also, it can convert in a three table: person, employee, customer. What are there? The person consists of its local attribute, name, street, and city. And lower level entity, employee and customer, consists its local attribute, say employee, salary is there, and as well as the all the inherited attribute, that is not only the name, street, and city. Okay. Similarly, in customer table, not only the credit rating is there, as well as name, street, and city is also there. So in case of person, name, street, and city. In case of customer is the lower level entity set which can form by the local attribute. Which one is the local attribute? This is the local attribute. And what are the inherited attribute? Inherited attributes are name, street, and city. Similarly, in case of employee, name, street, and city is the inherited attribute, inherit from the higher level entity set person, and local attribute salary. Okay. So in this method, Uh, in this case, actually, uh, this person, if the specialization or generalization is the total towards the person, then the person entity set information may not be, or for that table is not required. So at that case, if it is a total, not other cases, so only these two tables are required. But but uh, but explicit table may still needed for the foreign key constant, and that is the main drawback here. The drawback is the, for that actually redundant. You can see here, you can see this one. This is the special case. You can see here the street and city is redundant. Street and city is redundantly stored in the three tables: person table, customer table, and employee tables. So this, suppose there may be possible the one of the person uh, who is both uh, as a customer and as a employee. Is it possible? Na? That means there some of the persons are there. Those persons are both customers and as well as the employees. So in that case, the, for that person, say person, say person, say Amit, and say Bikas. So Amit and Bikas both are customer and as well as the employee. So address of the Amit and address of the Bikas are duplicated in person table, as well as the customer table and as well as the employee table.
Sir, one thing, sir. Sir, could you click on hide, sir, because we can't see the last line, sir. It says stop sharing, sir. Hide, sir. There is one dialog box at the bottom, sir.
Oh, sorry. Oh, that is
And
abstract.
yes, sir. Okay.
Just a minute. Just a minute. Okay, just a minute. I think it's fine, na? Right now.
Uh, yes, sir.
So now, in that case, what happens? For the person Amit and as well as the Bikas, both of them are the customer and as well as the employee. So address, or more specifically in this example, street and city are redundant in both the table, customer table and as well as the employee table. So this redundant not only the increase the space use, memory space use, it also increase the complication during the updation time. For example, suppose Amit change his address, say city from Durgapur to say Asansol. So at that time, that address city need to be changed in the both the table, customer and as well as the employee. Person table is required, of course. The Amit, what is the address that can be reflected in the person table. But because the Amit as a customer and as well as the employee, for that need to be changed in the both the table, customer and as well as the employee table, the city value and as well as the street value. So for that, if that updation is done by mistakenly in one place, not in the another place, that is the city is changed from Durgapur to Asansol in the say employee table, but it is not reflected in the customer table. So it is the anomaly problem, or that can lead to the database in a inconsistent state, because the customer, the city is either Durgapur or Asansol. Okay. Uh, so so in that case, this there is a redundancy is there. This is the problem. So this is the case of generalization and specialization. So I
Uh,
think the
so
previous
one
method
question,
one is the better.
sir,
Please,
one
what is the
question, sir. Sir, I didn't
uh,
understand the explicit tables may still be needed for foreign key constraints, sir.
foreign key constraint?
Yes, I didn't understand that part, sir.
That is actually I have not till discussed the details about the foreign key. Means here actually you can see the this one, the name. This name is the primary key of the which table? Person table. Okay.
Yes, sir.
You can see here name is present here in the customer table and as well as the employee table. So in that case, the name of the customer table act as a foreign key. That is name act as a foreign key in which table? Customer table, and primary key in the person table. Similarly, name act as a foreign key in a employee table. Name is a foreign key here, but name is part. I mean primary key of the person table. So any change in the person table, the name, maybe the street or city, street and city as well as need to be changed corresponding where the foreign key is there. That name is present. Okay, to maintain the database in a consistent state. So this one is needed. Okay, this is the foreign key. This sorry, name is the primary key in the person table, and name is a foreign key of the customer table and as well as the employee table. That basically reference. Okay, it will be more clear later, I think. So next one is the aggregation. Means how we can convert in the aggregation from ER diagram to the tabular form. To represent the aggregation, create the table which containing the primary key of the aggregated relationship, primary key of the associated entity set, and if any descriptive or local attribute is there. It will be better. For example, say this one. This is the this is the aggregated entity set. This is work on entity set. This work on entity set, there actually it is aggregated three entity set: employee, branch, and job by the work on relationship set. The details of that I already discussed in our previous class. But now point is actually how we can convert this one in a table. So in that case, the aggregation is the manages. That is the this aggregated entity set, and another entity set is uh, I mean related via the manages relationship. So this manages relationships, when you convert for that one table, the name is the manages. The manages table is actually what are the column is there? Columns from each of the higher level entity set. What are the high level? Means each of the primary key of the higher level entity set. That is the actually primary key of the work on relationship. What are the primary key of the work on relationship? The primary key is the primary key of employee, primary key of branch. That is, what are the primary key for that? If we consider the employee ID, if employee ID is not there, only the employee name is the act as a primary key, then we can write here employee name. Okay, say employee ID, and in case of branch, what is branch name? Branch name, and in case of job, the job title. Okay, these three are the primary key of the work on. So when we convert this one in a table, that consists the primary key of the work on relationship, that is this one, and as well as the primary key of the manager. What is this? Manager name. So these three are the primary key. These three are the primary key of the work on relationship. This is the primary key of work on relationship. Okay, is it clear? So just a minute. So finally, for the managers, what are there? Uh, the it consists a column comes from the primary key of the work on relationship, that is this one, and this one, and manager entity set. What is the manager entity set primary key? Manager name. Okay, this is the table for managers, and other tables are table for employee, table for job, table for branch, and table for manager. Okay, is it clear?
Sir, is title the job name basically, sir? Like the primary key of job.
Title is the primary key of the job entity set. Okay, basically
Okay.
job title or something is there, but for simplicity I can write the here actually title is there. Title and other attributes are also there. The title act as a primary key of the job. So primary key of this employee, primary key of job, and primary key of branch is the primary key of the work on. So table or attribute of the manager's relationship is the primary key of the work on and primary key of the manager. What are the primary key? What is the primary key of the work on? This. Sorry. This part is the primary key of the work on, and this part is the primary key of the manager. So all of these are column for the managers. This is the aggregated relationship. And in case of others relationship, other table, for employee table, all the attributes of the employees correspond to the columns of the employee table. Similarly, branch, all the attributes of the branch entity set correspond to the column in the branch table. Similarly, job and as well as the manager table. So here actually, finally, for this, how many tables are there? The tables are, the first one is the for the employee, second one is the branch, third one is the job, fourth one is the work on relation, fifth one is the manages, and sixth one is the, it is visible, manager. Okay, so this one, for that need to convert in a table. Just a minute. One table for this one table for job, one table for branch, one table for work on, one table for aggregated relation managers, one table for manager entity set. Okay, so is it okay? And in that case, the work on table, this table, work on table is the redundant in that sense. The information which actually stored here, that is also stored in the managers. But if we consider the managers, this managers table consists the null value. this managers table consists of null value, then at that time work on relationship, work on table is not required. That at that time it act as a redundant. But if we don't allow the null value in a managers relationship, managers relationship or maybe the managers table, at that time work on table is required. If we allow the null value, then work on table is redundant, no required. If we don't allow the null value in a managers table, then work on table is required. Okay, any other question? So entity relationships chapters is complete. Just do you have any question? Otherwise, I can proceed to my next discussion. Any question or query?
Sir, I did not understand. Sir, is method one preferred, sir, when we deal with the
Generalization and
generalization?
specialization. Yeah.
So
Method
basically,
one is better.
so basically, the drawbacks are along with the redundancy. There's also the chance of no consistency in case of changes.
Yeah, redundancy actually redundancy leads a inconsistent state sometimes. Problem is possibly inconsistent state. So unnecessary redundancy. Okay.
Okay.
So that example actually in the method two, the city and street, uh, which information for a particular employee stored in the both table. Which table? Employee table and as well as the their customer table is there. Employee table and customer table. So the same information for the particular person, say Amit, he has act as a employee and act as a customer also both. So street information and as well as the city information of that employee of that person is present in both the table employee and as well as the customer. And this redundancy creates the problem during the updation time or maybe deletion time or insertion time. Suppose if we want to delete the person Amit, so there may be chance the city and address is changed in one place but not change in another place. Or maybe if we want already told the update, the city value is changed from Durgapur to say Asansol. So at that time that fact actually reflected in one table but not reflected in another table. So it leads to the inconsistent state of the database. Okay. So for that method one is better. Okay, so we start our next chapter. We can discuss today a little bit and then tomorrow. One thing, tomorrow my class is in morning. Na, first up 10 o'clock or 11 o'clock? Just forget. 10 o'clock. Is it, na?
Yes, sir. Yes, sir. Yes, sir.
10 o'clock tomorrow morning. Okay. So next one is the basically relational model and as well as the pure query language. Here also the same thing. Most of the portion I can discuss from the 11 o'clock. Okay.
No, it's on 10.
Tomorrow 11.
The routine says 10. Not sure.
Okay, just a minute. I already written. 1 minute, please. Sorry, it is written in my 11 o'clock. Okay. Tomorrow, instead of 4 o'clock, that class is shifted in 11 o'clock morning. So the relational model and the pure query language. The pure query language I already told in my beginning class. This actually forms the basis of the query language. The query language means uh, is a language by which we can uh, ask for information or retrieve the information from the database. Okay, so this pure query language is the basis to form any other commercial query language. So here most of the discussion from the books of Cort, and here we have basic idea of the relational database. Some already discussed in my introductory class, and query language, the pure query language. One is the relational algebra, tuple relational calculus, and domain relational calculus. So first, the basic structure. The um, before that, am I audible? Is it? Na?
Yes, sir.
Am I
You
audible
are
or
audible. Yes,
sometimes
sir.
actually due to network problem? Okay, maybe disconnected sometimes. You already know the in case of relational database, that is the that follow the relational data model. The relational database consists of a collection of tables, and each of which is assigned a unique name, that is the table name basically. For example, if we consider the account table, and that account table is described by a number of columns or number of fields, or maybe say the number of attributes also. uh, that is, for example, in case of account table, there is a attributes are, or maybe the column names are account number, and another one is the balance. That is, column names are also unique. Okay, so in that case, the row, the in a table there are number of rows are there. The rows,
Sir, are you drawing
the
something
row
on
in
the
a,
board, sir?
no, I am not doing actually, just uh, I'm telling you, means before that, actually that is not written here actually in that slide. So about the relational database means the things actually I already maybe told you the in my beginning on introductory class. The row in a table that represent a relationship among a set of values, and since the table is a collection of I mean the collection of relationships, which one is the there is a কি বলবো, close correspondence to with the tables, that is relationship and tables, there is a close some correspondence are there. So in just a minute. Okay. uh, Formally the relationship sorry, relation R is a just subset actually comes from the d1 d2 d3 up to dn. The here actually the relation is a n tuples, where one of the attribute or one of the values comes from ai is comes from the domain di. Okay, for example, uh, if we say the relation is the customer name, sorry, not a relation, it's customer name is the, say this one is the d1 d2 d3 so on. This is a d1 d2 customer street d3, like that. That is the domain of customer name is the, say, joy, sumon, because, osit, and so on. So the relation r in that case is the taken from this. Okay, is a relation over customer name, customer street, and customer city. That is, it is a, in this case the relation is a three tuple. Okay, three tuple. So this one is the just mathematical relation, like, so it's better actually we come in straight to our point. Now each attribute in a relation has a name, you already know. The set of allowed value of
Sir,
each of
could
the
you go to the
attribute called the
previous slide
domain of
one,
the.
sir?
Okay.
I have one doubt, sir.
Please tell me.
Sir, could you explain, sir, the R structures? I didn't understand the R structures, sir.
Uh, this one.
Yes, sir.
the relation are means there are the customer name. Customer name is the here set that consists the value. This is basically you can say the D1. The Joy, Sumon, these are the set of values are there. Similarly, customer street, there are set of values are there. The relationship, relation is basically we talk about the ER diagram. For that, instead of relation, I sometimes actually uh, pronounce the relationship here relation. The relation uh, R is the actually subset of the values stored in this set. Okay, it is a n tuple by definition, but here actually it is a three tuple. In this example, three sets are there: customer name, customer street, and customer city. But you may consider think like this is a domain like the what are the domain range? Joy, Sumon, Vikas, Osit. So R is the subset of all of this. That is customer name, Joy. Here, just I change the color to be more clear. You can see here in this case R is a three tuples, that is A1, A2, and A3. Okay, so A1 actually comes from A1 comes from where? A1 comes from here. Similarly, A2 comes from here. A3 comes from here. Okay, so you see Joy, this one actually comes from D1. This one comes from D1. Main comes from D2. This is comes from D3. Similarly, here Sumon, which comes from D1, North comes from D2, and Durgapur comes from D3. Okay, is it clear? So here each values actually the comes from D1, D2, and as well as from D3. Is it okay?
Yes, sir.
Okay, you can read from the books. This is similar to the relation in mathematical. So here you know the attribute has the one of the name, or that name is the unique name, and set of allowed values actually called a domain. And attribute values are normally required to be atomic. That is, atomic means it is indivisible. So for example, the multi-valued attribute or composite attributes are not atomic because that can be divisible. The composite attribute is divisible, and as well as the multi-valued attribute consists of multiple values. So it is not the atomic in that case. And special value null is a member of every domain. Okay, null is the member of every domain. Domain means, I think it's clear in our previous slide. Yeah, just like these are the domain. The customer name, what are the domain? Domain is the Joy, Sumon, Vikas, Osit, and so on. And null value, we can discuss this one later. Null value actually sometimes create the complication. Okay, for number of operation. So in our initial discussion, we ignore the null value or effect of null value. Later, we can consider the effect of null value or what problem actually raised due to the null value. Now, say A1, A2, these are the set of attributes. Capital R is the relational schema. Capital R is the not a relational schema, which is a consists a number of attributes, n number of attributes. For example, customer schema. Customer schema. Just in my beginning class, I told you the schema and instances. Can you remember schema and instances? Schema is the basically structure. If we logically, for understanding purpose, if we consider the variable declaration, say int x semicolon. What is the meaning of that? we can define a one of the variable x which can hold integer value. Is it na? That is basically the this is the design structure. That is the schema here in relational database. But when at a particular instant of time or particular moment of time, x contains some value. Maybe x contains a value 15. So that is called the instances of variable x. Similarly, at a particular time, the content of the database or contents of the relational schema is called the instances of the that relational schema. So, so at a particular time, customer schema consists the information about different customer. What information? Customer name, customer city, customer name, customer city, and customer street. Okay, this set of information is called the instances of the customer schema. Is it done? This one I have already discussed in my beginning class. So here the R is the schema, the customer schema. Basically, you think like a structure. The customer schema, what are there? Customer name attribute is there, customer street is there, and customer city is there. Okay. Now, small r is the relation, and capital R is the relational schema. This relation small r on the relational schema R, that is a relation on relational schema R. That is, what is this? Is a relation small r on the relational schema is capital R. For example, here customer is the relation on the relational schema customer schema. I can again repeat. R is the capital R is the schema that consists of structure. What are the structure means? This relational schema consists what are the attribute? Say A1, A2, A3. These are the attributes. These are the attribute. This is the relational schema. And small r of R is the relation on the schema capital R. For example, customer schema. This customer schema consists what are the attribute? Customer name, customer street, customer city. And this customer is a relation on the customer schema. And current value, whatever actually I told at a particular instant, particular moment of time, the current value of a relation are specified by a table. Okay, that is called the relation instances. Relation instances. Okay, and relation instances is specified by a table. That is, you can just like a think any relation is specified by a here table. And element T of relation R is a tuple which represent the row in case of table. That is, in case of relation or mathematical relation, we can say the tuple, number of tuples are there, and each of the tuple is represented here row in a table. For example, here this is the customer table. This is the customer table. Okay, and this customer, this is also equivalent to a relation. This relation customer, small r is the relation on the relation schema capital. That means this is a relation. This relation on the relation schema customer schema. Is it the customer schema, which consists the attribute customer name, customer street, and customer city. Okay. In relational database, this relation are represented as a what? Relation is represented as a table in relational database. Okay, that is, I already told that these are the name of the column or name of the attribute, and these are the these are the tuples. These are the tuples, or you can think like a rows. These are the tuple or rows. If we think it is a relation, then it is called a tuple. If we think it is a table, then we can call the row. But the terms are actually tuple and rows are interchangeably used in case of relation and as well as the in case of table. That is, in case of table, sometimes instead of row, I can tell you, I can told you the it can be a tuple. Okay, tuple of that table. But tuple is actually mainly concerned with the relation, and row is concerned with the table. But both are actually same. Means the each of the tuple represent here each of the row. Is it clear now? That is, suppose that this tuple, Joy, Main, Kolkata. That is, you can see in our previous slide. Here. Oh, sorry. This one. You see this one. Joy, Main, Kolkata. Next one is the next tuple is the this is the tuple T1. Next tuple is the tuple T2. This one is the tuple T3, and this one is the tuple T4. You can see tuple T4 is the Osit, West, Durgapur. You can see here the tuple T4, that is tuple T4 is the Osit, West, Durgapur. This is the tuple T1. Or in case of table here, it is a row. Okay. The order of the tuple is irrelevant here. The tuples may be sorted in any arbitrary order. So that is basically it is unsorted. So this is a account relation, or you can think like it is a account table. If we think it is a relational database. Okay, is it clear? That is account. We can consider as a relation and as well as the table when it stored the value in case of relational database, and it is unordered or unsorted. The relational database consists of number of relations or number of tables, and information about a enterprise is broken into a parts, with each relation storing one part of the information. That is, the whole information of the particular enterprise is divided into number of parts, and each part is information about each of the part. It's stored. I mean storing in a correspond to a one of the relation. For example, in a banking system, the banking system, all the information of the banking is divided into number of parts. One part stores the information about the accounts, another part information about the depositor, another part information about the customer, another part information about the loan. Okay, another part is the information about the say loan. We store the information about the loan. So this each of these are actually one of the relation or one of the table. Multiple relations, or you can think like a tables. Okay.
Sir,
Please tell me.
sir, actually, we have an elective class after this. Sir.
You have a
elective class, sir, now. Oh, 6, sir.
elective class.
Yes, sir.
Open elective, sir.
But I told you the. Please
so
pardon
open
me.
elective.
Open
So
elective.
open elective, sir.
Measurement.
Okay, just a few minutes. But that class actually changed. The open elective class slot is in different time, no?
Yes, sir. Actually,
That
it was
class
shifted around to this.
Sir, extra class है.
today is the extra class. But actually, I told yours here already. Means this class, the 5 o'clock class. Actually, maybe I can extend half an hour more. That can be treated as a 2 classes. So okay,
Yes,
uh,
sir.
no problem this week. But just a few minutes only. So here storing, you can think like this one, the why information is divided, information of a particular organization or particular enterprise is divided into number of parts or number of segments. What is the necessity of that? The importance is, if we store this one, suppose the banking, we can either divide the different information in a different part. The account part actually contain the store the information about account, loan part actually contain the store the information about the loans, customer contain the information about the customer or store the information about the customer. But if we are not divided into number of parts, instead of that, suppose we can consider only the bank is the relation, or maybe the bank is the one of the table, and that can contain all the attribute values. So what is the problem here? There is a repetition of the information. There may be the two customer own one of the saving accounts, that is joint account holder. So at that time, for that both row is required, or maybe suppose one of the customer having a account but not taking a loan. So in that case, some of the informations are in bank, some of the attribute values are there, customer name, loan number, and as well as number, loan amount, and some other information that contain the null. Okay, because they does not take any loan from the bank. Okay, so it can actually creates the lot of problems. What are the problems that we can discuss when we talk about the normalization chapter? Okay, this is the design issue, the details design issue or design process of the relational database is based on the theory of normalization. Okay, or defined normal form. More specifically, defined normal forms are there: 1NF, 2NF, second normal form, third normal form, Boyce-Codd normal form. Okay, so uh, so uh, so for that, the all the information are not stored in a single relation or table. Okay, so rather than this, it can divide into number of relations. Each of the relation consists of part of the information, that is the some subset of the information about the organization or about the enterprise. Okay, for example, this is the customer relation consists of this information regarding information about the customer. This is the information about the depositor, that is the depositor relation or the depositor table also. Okay, the table and relation the more synonymously used. Okay, when the data is stored, it is called a table, but more specifically nowadays it is used as a table, the term table. And this is the ER diagram, the banking system, whatever we can consider in our query later. This is the here actually account, branch, customer, and loan. These are the 4 entity sets are there, and 4, I mean, relationships. This is the relationship, this is the relationship, this is the relationship, and this is the relationship. What are the key? That one I already discussed, but here just revision is there. Okay, you have a class is there, na? So it's better actually we can discuss it in tomorrow.
Okay, sir.
Okay, any question? Do you have any question, please? Any question? Yes or no?
No, sir.
No, sir, it was clear.
Just a minute.